Sterilization and disinfection. This is the part 2 of the previous lecture. So the learning objectives. At the end of the lecture, the student should be able to define sterilization and disinfection, describe the common substances and processes used to achieve this outcome. First we'll start with the definition. So what is cleaning? It is a process which physically removes contamination but does not necessarily destroy the microorganisms. So here the prerequisites before decontamination is by disinfection or sterilization of the instruments. So the next definition is disinfection. It is done by using an agent that destroys germs and other harmful microbes or inactivating them, usually referred to chemicals that kill the growing forms like the vegetative forms but do not resist spores of the bacteria. So here the spores of the bacteria are spared. Fine. Next, antiseptics. It is the destruction of the pathogenic microorganisms existing in the vegetative state of living organisms. Sterilization. Any process which is physical, chemical that will destroy all the forms of life including the bacterial, fungi, spores and viruses. So sterilization may be done by using physical methods and so in physical methods we have dry heat, example oxidation, moist heat which damages the bacterial cell wall or the pathogens by denaturating the proteins. Next, radiation. Here the cell enzymes are damaged and the DNA also is damaged. Filtration. So here the organisms are trapped through the filter. So the filter is small enough to filter the larger organisms. Ultrasonic vibrations. It coagulates the protein and damages the cell wall. This is the mechanism. So dry heat. So the instrument which uses dry heat for its working is the hot air oven. So it is used on oils, waxes, flaming, red heat, incineration, which is the ultimate sterilization used to disposal of hospital waste. Incineration nothing but burning at higher temperatures around 1000 to 2000 degrees Celsius. Wet heat. So it can be defined as disinfection less than 100 degrees. For example, you have pasteurization. So here what happens, the milk is boiled to around 72 degrees Celsius for 20 seconds, then boiling at 100 degrees Celsius. So it is limited use as spores may be resistant, boilers may be misused. Then low temperature steam disinfection, it's around 75 degrees Celsius for 30 minutes. So it is used in conditions like instruments like ventilator tubings. Next is autoclave, where high temperature steam plus pressure is applied. So the autoclave has the same principle as that of a pressure cooker. Dry heat. Incineration. So here the materials objects are exposed to hot fire. The objects must become red hot as the inoculation loop is used in microbiology. Then it is used to dispose the tissue or the carcasses. Carcasses are the dead remains of the animals. So the efficacy of dry heat, that is incineration method, is complete sterilization. Next is hot air oven. Here the sterility requires 1 hour of exposure at 170 degrees Celsius. Powder and non-aqueous liquids like paraffin and Vaseline may be used. Used in animal care facilities and useful in domestic application. The efficacy here is complete sterilization. Moist heat. We have hot water which is used to clean and sanitize surfaces. Addition to detergents increase the efficacy by emulsifying oils and suspending soil so that they are rinsed away. The efficacy here is incomplete sterilization. Okay. Next is boiling. It requires 3 hours of boiling to achieve complete sterilization. Boiling for 10 minutes will destroy the vegetative bacteria and the viruses but not the spores. Addition of 2% calcium carbonate or sodium carbonate will inhibit the rust and increase the efficacy. So used for field work, efficacy, it might be complete sterilization, but complete sterilization is not warranted. Next is steam. It is similar to boiling, but the temperature here is the same. The exposure to steam around 90 minutes kills the vegetative bacteria but not the spores. The efficacy is incomplete sterilization. Next is steam under pressure. Pressure increases the boiling point such as the temperature of the water, which becomes high at around 100 degrees Celsius. So, okay, here what happens, the temperature is raised more than 100 degrees Celsius. So autoclave, which has a typical setting of 120 degrees Celsius, has 15 psi. Psi means per square inch, okay, of for around 15 minutes, or around 121 degrees Celsius at 30 psi for 3 minutes. The autoclave uses steam under pressure to achieve sterilization. This is the most efficient and inexpensive method of sterilization for routine use. Here you have complete sterilization. So the advantages are they are non-toxic, they are quick and cheap. The disadvantage is only heat resistant materials can be used and not used for plastic, electronics and other metals. Next is filtration. So you use the liable fluid and on air supplies. Gamma radiation uses disposable plastics like sealed packs. Only specialized centers can use. Next is ultraviolet. Low energy ultraviolet radiation is a sterilant when the objects or the items are placed in close range. UV radiation has no penetrating ability, so it is used to sterilize the rooms. UV is very irritating to the eye. There might be complete sterilization possible there. Next is gamma radiation. The ionization radiation produced from a cobalt 60 source is used. It has good penetration ability in solids and liquids. Used extensively in commercial preparations of pharmaceuticals, biological products and disposable plastics. Here you have complete. Next is fluid filtration. Forced through a filter that is either positive or negative pressure. Filter is most commonly a synthetic filter with micropore openings, used in sterilized culture, buffers and pharmaceuticals. Pore size is around 0.45 micrometers, which removes most of the bacteria. Microplasmas and viruses require 0.01 micrometer to 0.1 micrometer sized filters. So they may be used in conjunction with a pre-filter. The efficacy can be. Next is air filtration. So here the example which we use are surgical masks, laboratory animal cages and air duct systems. Fibrous filters made up of various paper products are effective in this condition. Efficacy is influenced by the air velocity, relative humidity and electrostatic charge. The efficacy can be complete. Next is ultrasonic vibrations like cavitation. High energy or high frequency sound waves pass through solution, creating thousands of cavitations or bubbles. These bubbles contain a vacuum as they implode or collapse, and the debris is physically removed from the objects. So the efficacy is incomplete sterility, and it is effective as an instrument cleaner. The factors influencing the ability to kill microbes. First is the strength of the killing agent, the time of the agent to act, the temperature, the type of microbe, environment around the area to be decontaminated, killed. So chemicals. So it depends upon the spectrum of the antimicrobial activity and the compatibility with the material. Next one is it's also limited to the danger of the chemical itself. So examples are halogens, alcohols, alkylating agents, ethylene oxide, phenolics, cetrimide and chlorics. Halogens. So examples are hypochlorites, which are household bleach, and chlorines. The advantage is they are active against viruses, spores and fungi. The disadvantage is it is inactivated by organic matter, freshness and pH which is critical. It is also corrosive to metals. So practical uses: 0.1% hypochlorite is used in general disinfectant. Strong hypochlorite is used in lab and on wounds. Extra strong, that is 1%, is used on hepatitis B virus or blood spills. Chlorine is used to treat drinking water and even Legionella. The iodophores and iodones. Okay, the advantages are they may be active against some viruses, fungi and spores. They are also inactivated by organic matter and they can stain skin. They may be irritant to the skin and are expensive. The practical use. So they are used as a pre-op skin disinfectant. Example like povidone iodine, which is commonly called betadine, is also used as a surgical scrub. as powder and on ulcers. Alcohols. Isopropanol and ethanol. Advantages: they kill the vegetative bacteria on clean surfaces in 30 seconds. Disadvantages: that they are inactive against spores and fungi. They are highly flammable. Need to be at correct percentage with water. Means the alcohol concentration should be around 65 to 80% for it to be efficacious. Practical uses: it is used in skin antiseptics before venipuncture, hand rubs, and as a disinfectant of trolley. So ethyl oxide, which is highly toxic and flammable gas which kills spores, used for bulky items such as heart-lung machines, can be used on glutaraldehyde liable endospores, and they are limited by. Next are the phenolics. So clear soluble phenolics like hycolon can be used as disinfectant on soiled surfaces. They are relatively inactive against spores and viruses. Hexachlorophane is used as a surgical scrub. Quaternary ammonium compounds like cetrimide can also be used in combination with other agents, and they have good detergent. Next is chlorhexidine. So it is used as general purpose antiseptic for skin and mucous membrane in many formulations like Savlon. Advantages are they are really non-toxic and good against Staphylococcus aureus. Disadvantages that they can support the growth of Pseudomonas aeruginosa, which is a very dangerous bacteria. So factors determining the usefulness of a chemical disinfectant. So spectrum of antimicrobial agents, it is right for the job. So you should understand whether the antimicrobial activity is correct for the job, and it should be used in correct concentration. Fine. So you can read this and have an understanding regarding this. Okay. The time of exposure, the inactivating material, so on. Quality control. The effectiveness of any method of microbial control must be monitored regularly. Verification of effectiveness of microbial control should be performed monthly. So the methods of quality control are recording the thermometer, thermocouple, chemical indicator, biological testing, Bovidix test, surface sampling,